On behalf of the team of Cornell Cooperative Extension Regional Dairy Specialists and Pro Dairy, we would like to welcome you to day 2 of our Net Zero for New York Dairies program. My name is Casey Havicus. I will be your host today, and I am one of the dairy management specialists at Cornell Cooperative Extension on the North Country Regional Ag team. So our next presenter is Dr. Tom Overton. Dr. Overton is a professor of dairy management and the chair of the Department of Animal Science at Cornell University. So I'll pass it over to you, Tom.
All right, so I'm going to focus mainly on enteric methane, and really because that's from a nutritional standpoint, that's one of the main ones I think we can kind of chase after. I'm going to just slightly rehash a few things from yesterday, although I'll do it fairly quickly. Just a reminder that animal agriculture, these are data from EPA that were summarized by Farm Bureau, account for about 2.5% of greenhouse gas emissions in the U.S., based probably on the older calculations and things like that. Dairy at around 0.7%, and then you see beef, and then swine and other are certainly much smaller. Sarah Place and I think and others yesterday talked about the life cycle analyses that Greg Thoma has done out of Arkansas, and that most of the emissions, greenhouse gas emissions, are associated with things that go on and related to the farm. Okay, so whether it's the feed side, crop production, whether it's enteric methane, whether it's manure management, so again, that does represent, even though we're a small percentage, it does represent opportunity areas for us. So I think Sarah and others alluded yesterday to the notion that we've made tremendous strides in a carbon footprint in the dairy world, and we really have, at least in terms of looking at carbon footprint of a gallon of milk. This is work that, again, Jude Capper, Dale Bauman did a number of years ago, again, reducing, by 2/3 between 1944, which is, I think Frank Mitloner noted, it was when we had 25 million cows in the US, to 2007, when we have 9-point-something million adult cows in the US. And, that just reflects, again, tremendous gains in terms of reduced not only numbers of animals, but feed requirements, land requirements, manure production, water needs, and methane production in 2007 versus 1944. Now, granted, we made a lot more milk in 2007 compared to 1944. Fairly recently, Jude Capper and Roger Cady revisited this to say, okay, what happened between 2007 and 2017? And this paper is available in Journal of Animal Science. And so, a couple notable things here. We see growth in milk production in that time frame. We see maybe slightly higher, number of lactation age females in the adult herd, although not hugely different. But what has been different, again, milk yield per cow is increased. Milk components, you see milk fat and milk protein here have really increased on that time frame as the industry has latched on to being priced on fat and protein yield largely and things like that. And so, we see a large increase here in energy corrected milk, in the same time frame, right? So if they look at things, per unit of energy or per million metric tons, I think of energy corrected milk, and we can go down the list from relative to resources, and then 2017 as a percentage of 2007, we see continued gains, right, in really pretty much all of these things. Okay, now granted, we make more milk, so again, as Sarah pointed out yesterday, our emissions are perhaps flat to increasing overall as an industry. So it is an opportunity for us, even though we're more efficient per unit of milk, to continue to make progress. And again, this just illustrates that if we have a bar chart here, the big chunks are still enteric and manure methane, smaller chunks related to enteric and manure nitrous oxide, on-farm electric CO2, cropping inputs, and then fertilized manure applications. So again, it still comes back to what comes out probably both ends of the cow. This slide's from Mike Van Amberg. One of the things I'm going to switch gears when we're talking about feed additives or feeding strategies here in a minute. I think one of the really important points, again, this is a slide from Mike Van Amberg, who's in the audience today, is milk yield per cow, and this is really the basis for a lot of what Jude and Dale and Roger have done, is really a huge influence in terms of the environmental impact, environmental efficiency. And so we need to keep in mind that anything that we do, right, that might decrease, say, enteric methane, okay, we need to be very conscious of what impact that might have on either milk component yield, other aspects of feed efficiency, because if we do something that may not, may decrease methane, yet we lose milk, right, or milk components, right, that's a huge offset going back the other way. And so we need to keep that in mind as we think about any of these strategies that we might employ to try to mitigate enteric methane. The other thing that comes about, and this is from one of Jude and Dale's reviews anyway, is that the carbon footprint per unit of milk varies widely depending on where you are in the world. And again, average annual milk yield per animal is a big driver here. And so that's here in green, the average milk yield, carbon footprint in blue. And again, you see these countries or regions of the world where milk yield per cow is higher, have lower carbon footprints per unit of milk. Those areas where milk production is much lower have much, much higher carbon footprints per unit of milk. Okay, so we need to kind of keep that in mind. And so, really, if you wonder how we, in some ways, how we made progress, progress in this area over such a long period of time, is that, anything that improves milk per cow, decreases the number of cows needed to make a unit of milk, or increase the feed efficiency, will reduce impact. And so we have a laundry list of things here relative to forage quality, diet formulation. Again, I'll talk about Monensin or feed additives here in a minute. Milking, increased milking frequency, better reproduction, RBST, which unfortunately is not a tool for most of us anymore. Despite 10 to 15% or 15% decreased environmental impact, and various things there. Transition cow management, decreased age first calving, raising fewer heifers, genetic selection. So there's all kinds of things that play in and are the basis for why we'll continue to make progress in these areas. Again, Mike Van Amberg leads our CNCPS modeling effort. This is the model that is really used in various forms to feed the majority of cows in North America and in many other parts of the world. CNCPS will predict fecal and urine excretion, nitrogen, phosphorus, as well as methane per unit of milk and ammonia potential. And again, one of the questions in the Q&A related to trying to convert that to N2O, and I engaged Mike on that. And Mike's like, it's on the radar, but not yet in terms of being able to convert. But you can see anyway in the model, methane per unit of milk, and again, the equations that Mike has put in there to do that are outlined in a 2015 paper, Journal of Dairy Science. So what about the feed additive side, right? So we have various things we might consider. I'll talk briefly about ionophores, right, variable reductions, and I'll talk a little about essential oil botanicals. We have things out there that are that you may see the trade names on, like Agilin or Mutrel. These are probably, I would say there's some variability in results, but probably maybe 8 to 10% reduction in methane. Lipids, there's interest to some extent in lipids, although this is a pretty modest increase in or decrease in methane for a percentage unit increase in lipids. So you're not going to feed a tremendous amount of fat, I don't think, to decrease methane production. 3-NOP, I'll talk about 3-nitrooxypropanol. That's probably the one that's got the most, I would say, research behind it at this point. And again, about a 30% reduction in methane production, and actually was approved a couple months ago in the EU with the trade name of Bovaer, but I don't know if it's being marketed yet. I don't think it is, but they're certainly readying for that. And then there's been lots of attention on seaweed or things that relate to seaweed or algae and things like that. And I'll talk about that too. As again, you see very large methane reduction. A lot of the very large reductions are from some of the in vitro work that's been done. So again, you'll get my take on that here in just a minute. So Monensin, right? Rumensin's been around and approved in the U.S. As a feed additive in 2004. Increased feed efficiency by 3, 4, 5%. Increased milk output, or upper milk solids, slightly less intake. Some of the earlier work suggested, maybe up to about a 20% decrease in methane output. Looks like it's probably more like an 8 or 9% decrease in methane output if you put things together. Perhaps some variability response that we probably don't fully understand, but it was one of those feed additives that are currently available and is pretty widely fed in the U.S. 3-NOP, again, it's a feed additive. One of the things that's it's somewhat attractive about it is I would compare 3-NOP to like a sniper on the methane production process. So we know what it does. It inhibits the last enzyme in methanogenesis in the rumen. It's got a low inclusion rate. That's also attractive. And from my perspective, it at least has received some production scale evaluation. These are data from Penn State, Alex Christoph's group that were published a few years ago now. They control, and then they had 3 doses or three feeding levels of 3-NOP, and you found even they all decreased methane production, and the low was pretty much just as good as the high level of 3-NOP in this particular study in decreasing methane. They also saw, when you look at the production data here, here's feed intake. This is in kilos. No effect on feed intake, no effect on milk or milk components, largely anyway. So that one of the disadvantages of 3-NOP is that there's no, at least from what's been done, at least where I can tell anyway, we don't see any other economic gain for the producer. And so that's a limitation there for sure, right? We don't see more milk component production necessarily. We don't see better feed efficiency, and it'd be great to have those to go along with it, and you get the environmental benefit as well. A lot of talk, a lot of hype on seaweed and things that relate to it. You get this one blurb here from 2020. Research shows specific type of seaweed cows methane pressure about 98%. Okay, I guess any time I think one of the things that you got to be careful on here is, anytime something affects an microbial ecosystem to the point where some output of that ecosystem is decreased by that much, you've got to be wondering what else is it doing in the system. Okay, what else is happening in that system? And a test tube, which is where work like this gets done, is way different than feeding to a beef steer, which is way different than feeding to a lactating dairy cow, who's going to be way more, where milk and milk component production are going to be way more sensitive to what goes on in that ruminal environment. So, but again, it's out there. This is some of the original work out of Australia. With some of the species, you see very large, reductions in vitro in this particular study. There's a really good review. Sandra Veen put it out in 2020. A bunch of co-authors on it who were kind of in this game, and really kind of zeroed in on this is a figure from that review, really kind of zeroed in on kind of what we really need to know and understand, and then what really needs to happen in order to bring something like this to reality. And frankly, we're still for the most part in the does it work stage. In what conditions does it work, and how does it affect the cow? And to my knowledge, we've yet to really have I would say even some sense of production scale work that's been done just to say, okay, how else does this affect the cow, and how repeatable are the effects and things like that. So Joe McFadden, I'll put it in the chat, just put an op-ed into the Hill that they picked up where, again, he expressed similar, voice relative to really needing to evaluate, put the effort in and resources in to evaluate whether this can fly and quit overhyping it before we really understand what it is. A quote from this paper, which I think is still holds, use of seaweeds for enteric methane mitigation, commercial studies are largely untested. Several in vivo studies, again, they're pretty small, in methane emissions, but, unclear whether we can repeat them in the long term and across different production systems. Okay. Last thing here, Dr. Kristen Reed, a colleague of ours, is also in the audience, and Kristen's leading the charge on what's called RUFUS, the Ruminant Farm System Model. And so that's a whole farm model that is really set up to evaluate, a bunch of different aspects relative to to the environment, including methane, enteric methane, greenhouse gases, and things like that. So I won't get into detail. This is really her show and the team that she's leading. But again, a very comprehensive model. We're really looking at all the processes that may influence things on farm, as well as output and economics.